Good morning and welcome to webinar 12 in the Building Smart program. This webinar is entitled Electrical and Non-Comfort HVAC Considerations. I'm going to go ahead and turn my camera off to save bandwidth, but I'll turn it back on at the end of the presentation during the Q&A period. Okay. So this webinar series is being brought to you by Michigan's two largest utilities, Consumers Energy, which broke ground earlier this year in January for their Sunfish Solar 2 solar park located in Calhoun County. It's going to be providing around 360 megawatts of electricity for about 70,000 homes and businesses starting in the summer of 2026. And DTE Energy, which earlier this year began operations on their 80 megawatt Pine River solar park, that's providing power to nearly 20,000 homes in and around Pine River Township over in Gratiot County, which is kind of like in the middle of the mitten. My name is Sonia Ponce. I will be your instructor for today. I've been in this business for about 20 years, and I've been really excited to do this webinar series in collaboration with DTE and with Consumers Energy, and also with my co-instructor, Chris McTaggart, who will be stepping in starting next week. We've kind of been going back and forth. I kicked it off, and then Chris did a couple of sessions, and now I've been back for the last couple of weeks, and I'll turn it back over to Chris to kind of line things up. But again, I've been in this business for about 20 some years, primarily in the HVAC and building performance improvement arenas. Now that we know a little bit about me, why don't you tell me who you are? So let's do our first poll, John, and see who we've got in the audience with us today. And let me switch windows so that I can see the poll. Okay. Looks like we've got, a nice round set of attendees today. So we've got some architects in the audience. Looks like the um, our usual builders and contractors are the largest number of attendees in the audience. So, but we've got a fair amount of architects and engineers, and we've got some code officials with us today. So, again, good morning to you all, and welcome. I hope that that this session proves informative and valuable for you today. What I hope that you get out of the session, what I hope that you walk away with, um, is the ability to talk about a little bit more about high efficacy lamps, why builders are putting them in the homes these days. So if you've built a new home and the homeowner was expecting to see a different type of lamp, or as you're discussing the lamps and the fixtures that are going to go into the home, why the high efficacy lamps are essential, right? We'll be able to talk a little bit about some new technologies, right, for lighting and for pool heaters. And then to discuss some of the energy efficiency benefits that many of the control features that we build into our residential systems have. How do these make these systems in the home as an overall building perform better, be more efficient, be more comfortable? right? So that the homeowner's experience is enhanced. And then we'll talk a little bit about why pool covers are essential as well. This might be an often overlooked energy efficiency feature that some folks, some homeowners may not realize how essential this is to the efficiency of the overall system. So we'll spend some time talking about those as well. Specifically, our agenda, we'll start off talking about lighting, then we'll jump into pool and spa heaters and those covers. We'll talk a little bit about sauna rooms and those heaters, snow melt, heat trace, and then we'll wrap things up with drain water heat recovery. So let's dig into the lighting and see what we've got going on there. So gas lamps. Most people may think, well, we stopped, making lights with gas, years ago. Why are we even talking about this? Well, it actually does still appear in our Michigan Energy Code, and believe it or not, there are still places, even here within Michigan, that we may be using gas for lighting purposes. Some homeowners and businesses may choose to use the natural gas lanterns for aesthetics, for their ambiance. They may be used in places, for example, like the Gaslight District in Petoskey, right? So there, that area is known, right? It's a historical district known for its gas lamps, right? And so whenever we do have these gas-fired lamps, whether they're independent or they're combined with electric lighting systems, we want to make sure that these lights don't have standing pilots. We talk a little bit about standing pilots later on when we get into pool heaters as well. But we've talked about standing pilots before, and we know that, for example, with gas stoves and other gas appliances, and it applies here for lighting as well, right? Those pilot lights can use a significant amount of energy over the course of the year. And that energy is what we consider to be wasted energy, right? Energy waste, because when you're not using the light, those pilot lights are still running. Right? And so, just as with electric lighting, we've made advancements in energy efficiency, and we want to, reduce the amount of waste. We want to do the same thing with these gas-powered lights, right? Even more so because we know that these pilot lights are total energy wasters. So whenever we've got one of those, we want to make sure that it does not have a standing pilot. For permanently installed fixtures, our current code requires that at least 75% of the lamps in those permanent fixtures be high efficacy, or at least 75% of the fixtures, right, have high efficacy lamps, right? So you could have, if you've got 4 fixtures in the home, you could have 3 of those fixtures have only high efficacy lamps, or you could have, if those fixtures happen to have 4 lamps each, right? You could have 3 high efficacy lamps in each fixture, and then 1 energy hog in each fixture. Now, you likely would not do that, right? That's not something that most folks would do. So more than likely, we're going to see 75% of those fixtures have those high efficacy lamps. Now, currently, these definitions for high efficacy lamps, this is what is included in the current Michigan Energy Code. But we may see that change, right? We may see a change with a change in code. There's not a change in code pending, right? Right now, that's not on the table. But we're always looking to the future because we always want to get better. And so if we were looking to the future, or if the homeowner were particularly interested in being efficient, then we may look to some different definitions for that minimum efficacy. And so then for lamps of any type, future codes may say that, the lamp efficacy needs to be 65 lumens per watt, regardless of what type of lamp is being used. And then for any fixture, they may say that that the fixtures need to be 45 lumens per watt. Now, one of the things that our current code exempts, and there are for every provision or requirement in the code, there's always at least one exemption, right? And the exemptions are there for various reasons, right? And to make our to give us flexibility in our designs, and to be able to apply a certain level of creativity and individuality to our designs. And so when we have those exceptions, they're typically bound by some rules as well, but they do again give us that flexibility to do various things. And so one of the exceptions that we have regarding lighting, particularly for residential applications in our current Michigan Energy Code, is that low voltage lighting, right, in particular, does not require high efficiency lamps. Right? Now, future iterations of the Michigan Energy Code will likely include low voltage lighting as well. But right now, it is something that is exempted. And low voltage lighting is it's a type of electrical lighting that obviously it uses low voltage rather than the standard household 120 volts, right? So low voltage lighting tends to operate somewhere between 6 and 48 volts. Typically you see it between 12 and 24, and we use low voltage lighting for a couple of reasons. One, it reduces the risk of electric shock, so it's a safer installation, particularly for wet environments. So we see this used a lot outdoors in our gardens and around our pools. We might see it in landscaping, other places that it might be used around the home, display cases. My grandmother used to have a lighted curio cabinet that sat in the living room, right? And so we would see low voltage lighting someplace like that. Or we might see it in desk lamps for task lighting. Or we might see it in some of the pendant fixtures that we see for chandeliers in dining rooms. And it's also used often for recessed lighting, right? So we see this being used around the home in a number of places. And as it is used more frequently now, the focus has shifted to include this in the efficacy requirements for indoor lighting. But again, that's not something that's in the Michigan Energy Code today. That's something that may be coming in the future. So some of the other differences between low voltage and standard voltage lighting, particularly for LEDs, because we're moving more toward the new homes being furnished with only LED lighting now, right? We've moved away from the incandescent. We've moved away from the fluorescent. We're primarily using those LEDs. And so the primary differences here, in addition to the level of voltage, right, is that those standard LEDs have a built-in driver. Now they have that, excuse me, they have that driver because the voltage in the house, that 120 volts, that's not the voltage that those LEDs typically use, right, to provide their lighting. So the home is providing AC current at 120 volts, and the typical LED is using a DC current, right, at a significantly reduced voltage. Right? So we've got these drivers, if you will, which is really kind of the transformer, right? It's taking the voltage from one level and reducing it to another level. And it's also converting it from AC to DC. Now, because these drivers are taking this higher voltage, they are kind of they're assuming or consuming more power than really what's needed by the system. And we know from the conservation of energy, right, that that energy has to go somewhere. And so it gets converted to heat, right? And that heat is a waste byproduct. So, if you've got, LED lamps in your fixtures, right, you know that you can touch that lamp itself and it gets very hot, right? Sometimes too hot to even touch, right? And so that is that waste heat coming off of that lamp. That waste heat can result in rapid burnout for the lamps, which can be a problem, particularly for homes with um, vaulted or high ceilings, where it may be difficult to get to and change a bulb more frequently, right? So we market LED lamps as having, an extended lamp life, right? Sometimes as many as, 10 years or more. But if, we're generating that excess heat, that reduces that lamp life and that can reduce that significantly. Low voltage lamps don't have because they have a remote driver, right? So the driver's not located right there at the lamp, generating all that heat right there. And in addition to the other thing about not being right there at the lamp, with the traditional LEDs, you've got a driver in each lamp, right? So that's a lot of heat being generated in each room of the house. With the low voltage lighting, you have remote drivers, right? So you can have, you have fewer drivers than you do lamps. Um, you still do get some heat generation, but that heat generation is not there at the lamp. It's not shortening that lamp life. And it's typically, above the ceiling. So it's not, adding heat to that occupied space either. Right? Some of the things that we may see with above code lighting, and I'm just really going to kind of touch on this a little bit. Chris is going to get into this in much more detail. Um, but for single family dwellings in particular, some of the things that we might see homeowners requesting when they want to do better than code, when they want to be more efficient. Um, they may be interested in that high efficacy, low voltage lighting. So they may say, I'm going to put in some track lighting, but yeah, I want to use, high efficacy LEDs for that. I don't want to use the standard LEDs. Or, I'm going to, even in my recessed cans, right, I want to use low voltage LEDs. We are beginning to see people request dimmers and occupancy sensors. These are things that we have traditionally seen only in commercial markets, right? But we're beginning to see them used in residential spaces as well. Right? Um, and New iterations of the Michigan Energy Code for residential applications, we may see some requirements for these things in those new codes. Now, again, we're not, new code is not on the horizon, right? But it is always out there, right? So we do expect it to change at some point. We just don't know when right now. But these are some of the things that we might see there, and particularly for exterior lighting that's greater than 30 watts. Some of the changes that we might see might be a little bit more significant. So here we might see requirements for automatic shut off for those lights, right? Um, Particularly when daylight is available, right? Lots of folks have coach lights on their garages that may sometimes they may be manually operated, right? So you have to turn your lights on at night and turn them off in the morning. But if you forget, right, then those lights are on all day. Some folks do have those coach lights that are operated by solar cells, so they are turned off during the day, but that's not a requirement right now, right? So we may see something like that coming. And along with that, uh, there may be some limits on the time that an override might be allowed to operate. So, overrides are, you've got a program in there and, you've got some sort of schedule, but something something is happening at the house. I don't know, you've got some workers going on, or let's say you've got an early evening gathering or something, and so you want the lights to come on a little bit earlier, and so you're going to override that. You're going to override the pre-programmed controls. Well, the maximum time that you can allow that override, right now that override would just last, and you would have to remember to put the lights back on schedule. Coming up for future codes, we may see where those overrides are limited to no more than 24 hours of operation, meaning that after 24 hours, the controls will automatically switch back to the pre-programmed state, or the programmed state. Some other options that you might see with lighting are color tuning. This is becoming very popular as well, where it's a newer technology. It's similar to um, tuning in the dial of a radio to get the exact station that you want. So here we can tune in, and we can modulate or adjust the lighting that we have, right? So we can do what we call tunable whites, right? So you can get the exact white light that you want, or we have warm dimming lights that dim to warm, or full color tuning, right? This is another example of some commercial technologies that we're seeing, um, you know, move into the commercials. I mean, move into the residential spaces, right? So, for example, with tunable white lighting, right? We may see, this type of technology where you're able to adjust the correlated color temperature, right? This allows you to, for example, to change the mood or the atmosphere to suit the activities or what's going on in the space, right? And so we have these different color temperatures that are measured in degrees Kelvin, and each one, kind of makes you feel a different kind of way in the space, right? So the warmer lights around, 25, 2700 Kelvin, right? These are the cozy lights. These are the lights that look like, the older incandescent bulbs, right? With that yellow tinge to them, right? Those cooler white lights, right? These are more energizing, and these might be used for getting work done, right? So you might have homeowners that want to um, be able to either change the correlated color temperature of the lamps in various spaces, or they may want different correlated color temperatures in individual spaces, right? So you may want, that warm, cozy light in the living room area. You may want, a more neutral light in the kitchen area, or they may want a brighter white in office areas, right? One of the things to be particularly attentive to when selecting correlated color temperatures is the outdoor lighting. Several years ago, I was working with an electrician to add some outdoor lighting to my home, and we spent quite a bit of time, picking out what the fixtures would look like so that they would, match the decor. And I kind of assumed that the electrician would, pick the right temperature for the lights, right? That he would look at the lights that are already out there and pick a color temperature lights that kind of, matched that. But he was an electrician, right? Not a lighting designer. And so that kind of was not something on his radar. And because I didn't specifically mention it, he didn't pay attention to it, right? So then I ended up with some warmer yellow lights outside and a couple of really bright, cooler temperature lights. And so then I had to go back, and make a change. And very often, sometimes with these newer LED fixtures, particularly the outdoor fixtures, there's not a lamp in there. It's just a fixture, right, with small LED modules in it. And so, some of the older technologies, you didn't have the ability to change the color temperature, so you had to buy a new fixture, right? And so you just want to watch out for things like that as you're selecting lighting. And here's just an example of what it might look like in um, different color temperatures in different spaces, and you can see how the ambiance, how the mood is a little bit different in the warmer room versus the cooler room, right? Um, okay. One of the other options is full color tuning, And this is something that might be of value to folks. And actually, the dim to warm as well as the white light tuning may be of value in this area as well. We have a lot of people, children, for example, that have light sensitivity for various reasons, right? And so we may want to modulate the level of light, or we might want to modulate the color of light, right? We don't often think about this, but the colors of light that we put into the space can enhance the color of the walls that the room is painted, or they can impact our mood, our behavior, how we feel when we walk into the space, right? So, for example, blue light, generates a calming peace, right? It gives you a feeling of tranquility. Yellow lighting is a little bit more, upbeat, more positive, more cheerful. Green lighting has, been known for, to enhance harmony, creativity, productivity, things of that nature. And so we may want to consider options for being able to tune the lights for a particular event. Let's say, you're having movie night, or you're having a party, you're having friends over. You may want to, be able to, the homeowner may want to be able to modify lighting for any of those purposes. And so this full color tuning would give them that option. All right. Let's talk a little bit now about pools and spa heaters. We talked about these a little bit when we talked about hydronic distribution systems, but here we're going to talk more about the technology and the controls. So we know that pool temperatures typically range between 78 and 86 degrees, depending on the activity that's going on in the pool and the age of the people who are likely to be in the pool, right? So, your typical adults are going to be somewhere between 78 and 84. They're going to find that temperature range to be really comfortable. But babies are going to like to have, or going to need to have that temperature warmer, right? And seniors, right, folks who are swimming to maintain good flexibility in joints, or they may be suffering from things like arthritis, right? They're going to want the temperatures in the pool to be even warmer. They may like to see it around 86 to 90, right? It just kind of depends on who the people are and what they have going on in the pool. But regardless, we're going to have a heater likely for these pools, right? And those heaters have some control criteria that is stipulated by the Michigan codes. Some of these may be found in the residential code, some may be found in the energy code, some of them may be actually be found in the mechanical code. Mechanical code would apply for multifamily residential buildings. We're primarily talking here about a single family, so it would either be in the Michigan residential code or the energy code. But one of the criteria for those heaters is that they have an on-off switch, and that on-off switch be located. Obviously, it's going to be outside the heater so that somebody can access it. But it cannot be. It cannot. Let me go back. I apologize. Gosh, what happened? Okay. So the on-off switch cannot be one of those switches that requires you to adjust the temperature of the water in order to turn it off. So if you've got one of those min-max knobs, that's not a switch that would be allowable here in Michigan. So we can't have one of those. We also cannot have a heater, a gas-fired heater that has a standing pilot. We talked earlier about that with the gas lighting and the fact that those standing pilots waste energy, right? And typically for a gas heater, if the unit had a standing pilot, it could be using somewhere, between 500 and almost 1,000 BTUs per hour of natural gas. And that would be, for the entire summer season, right? And so that while that may not be a lot of gas for the individual homeowner, right? As it, would amount to, maybe $15 for the season. And but if we looked at all the pools across the state, right, that are using, and we've got over 283,000 pools estimated to be in Michigan. If let's say half of those are using natural gas, and let's say half of those are using standing pilots, that could be a considerable amount of energy waste across the state, over 750,000 CCF, right? And at an average rate of, around a dollar and some change per CCF, that's $750,000, right? That the utility companies could save, that the state could save, that homeowners, that ratepayers could save by getting rid of these, just the standing pilot here. And so if we think about that amount plus lighting plus other things, things like stoves and other gas using appliances, the more standing pilots that we can eliminate, the better overall for the homeowner and for the utilities as well. Those pool heaters also have to have a time switch that has to automatically turn the heater off based on a schedule, right? Again, we've talked earlier about the fact that there are exemptions and exceptions to just about every provision, but in general, we've got to have a timer switch for those heaters, right? This is going to help improve our energy performance. It's going to help improve pool temperature consistency, right? And it's also going to help prevent corrosion in the pool heater, right? Because it's gonna, and how it helps prevent corrosion is it's going to reduce the likelihood of condensation buildup, right? So you reduce condensation buildup, so you don't have corrosion. Your pool heater lasts longer, right? So you've got longer equipment life. And so you want to use these timer switches for example, at night when when you're not going to be using the pool, right? You want these things to either be off or significantly reduced, right? Likely off, right? So that you're not heating the pool when you're not using the pool. Just a little bit more on the piping requirements, and specifically some of the controls that are required for the pool heaters. We've got a safety device in here that's going to prevent the pool, the heater from overheating, right? And potentially causing, an explosion, right? With there was excess pressure in the water system, right? So we've got this pressure / temperature relief valve that is sized for the heater, right? It's typically going to be, opening up or at around 210 degrees or 75 psi to again eliminate overpressurization and over temperature situations. And just as a, a note here for the contractors in the space, this is something that we want to make sure that we're including in our annual maintenance program, right? So oftentimes, somebody a homeowner may have a pool service provider providing their service for the pool. They may or may not include the pool heater in that, but we want to make sure that if we're providing those services, that you do have an inspection for that relief valve included in your checklist of things that you're looking for, that you're looking at around the home. We also have a bypass valve that is installed. This is so that when the heater's not operating, we're not running water through it. That's because the heater provides a increased level of resistance that is going to increase our pump energy use. And so we don't want to do that. So that we're going to have this bypass valve here so that when the heater's not on, we can bypass it, right? And we also, in addition to, when the heater's off for general purposes because we're not heating the pool. We also want to make sure that we use that bypass valve if we're shocking the system, right? Because that chlorine could damage the heater, and so we don't want to run that chlorine water through the heater. And so when we're doing that, we want to make sure that we've got that bypass valve in place as well. And similar to other overrides, because this bypass valve is kind of like an override. And so similar to other overrides, this bypass valve has a maximum time that it can be used as well. And that, just like the lighting situation, is 24 hours. So the max time that you can have an override in place, or an override controlling the system, is 24 hours. Pool sizing. You want to make sure that that the heater for the pool is properly sized based on the size of the pool itself, so the surface area of the pool. You want to take into consideration the temperature rise of the pool. So what's the difference between the pool temperature, the pool water temperature, and the air temperature, the average temperature outside the pool? And for sizing purposes, you want to pick the coldest month of the year that the person's going to be, or that the homeowner's going to be using the pool. And then you want to look at the heating speed. How quickly do they want that temperature rise? How quickly do they need to heat that pool up, right? Those are the considerations that we want to make sure that we use. And so we want to make sure that these pool heaters are properly sized, that they're not undersized, because then they won't perform. And we want to make sure that they're not oversized. We talked about the importance of right sizing equipment a couple of weeks ago. And we know that that's important for performance and for energy use. Some above code options with pool heaters, advanced controls on these. So pool heaters can be high efficiency, right? So you can get them high efficiency. They can be low NOx, which are would help reduce air pollution, right? Provide better outdoor air quality, right? Right now in Michigan, we're having some poor outdoor air days where they're telling us to kind of stay inside because of smoke and things coming from Canadian wildfires and moving into our airspace. But even in your own backyard, right? Homeowners could be polluting their airspace with low efficiency, gas fired equipment, right? So using low NOx, high efficiency equipment can improve that outdoor air quality. They can also do things like include digital controls, right? So they can include controls that have, they have remote systems, they have microprocessors, they have digital displays, these things that, that are constantly telling you what the temperature is. They might provide assistance with troubleshooting, right? The gas heaters as well. Error codes can tell you, for example, exactly what's wrong with the piece of equipment. So those are some of the things that you may see homeowners requesting in their in their pool heaters. We also have various technologies that could be used for above code options for pool heaters, right? So homeowners may want to employ a heat pump system, which a heat pump for a pool heater would act similarly to a heat pump for a water heater or a heat pump for home heating and cooling, right? Instead of generating heat, it is moving heat from one location, in this case, the outdoor air, into the pool, right? So you're going to get improved energy performance, reduced energy costs, right? And in addition to providing, pool heating, there may be instances where, the pool water is too warm and they need to cool it down. The heat pump, they have that option to do that. Another option is to use solar technology, right? This provides even greater energy savings here, right? They're not using anything other than what's available for free from the sun. Of course, there's the installation cost, but the energy use itself is free. Okay? So this is the greenest technology that someone might use for their pool heating. And we can see here what the differences in cost might be in terms of operating cost for these various technologies. And so we can see that a heat pump here in Michigan with an average COP of 5, coefficient of performance of 5, may cost a little bit more than the natural gas or the high efficiency natural gas heat systems. It's because natural gas in Michigan, because we have such an abundance of natural gas here, and because we buy natural gas throughout the year and store it for winter use, our prices are really low here. And so the heat pump technology may not be as cost savings. You may not see as high a cost savings as you do with some of the gas options, but it still is a significant cost savings. And there are other benefits to the heat pump as well. Again, the ability to heat and cool, you don't have the fossil fuels at the space, right? Things like that. But of course, that solar, right? No utility costs, right? So that may be, a very attractive offer for some homeowners. Pools and saunas and spas, right? They lose a lot of energy, a lot of they lose water, right? From a number of various sources, right? Because the pool is heated, so you've got some evaporation going on. You've got some radiation. They're exchanging water with the sun. There also, that the heat that you're putting into the pool is being, you're putting it into the water, and that's being disseminated through conduction, through the pool, through the ground. And also, depending on what the relative humidity of the air traveling across the pool is, will impact the level or the rate of evaporation of pool water. And every, that as that pool water evaporates, it's taking heat that you have input into the pool. It's taking that heat out as well. And so, one of the best things that we can do for our pools is to include a spa and pool cover, right? And our code does require that because we know that they help reduce losses, right? And so they can reduce those losses between 50 and 70%. So right now our code does require that we have them, unless you've already got your pool heating is being provided from some site recovered energy, which would include solar, right? There are different types of pool covers. Basically, all you really need is, it could be as simple as a large sheet of plastic, but it's better to use something obviously that would be designed for pools. They can have, special materials. They can have UV stabilizers in them, and that would make them perform better. For example, an outdoor pool could absorb 75, 85%, for example, of the solar energy that's striking the pool. These pool covers can help reduce that, right? 5, 10, 15 percent for those that are transparent. For those that are opaque, it's even greater, right? 20, 40, 45%, right? These pool covers can be manual, they can be semi-automatic, or they can be fully automatic, right? So the manual one, somebody's got to come, they've got to pull the cover over. The semi-automatic, it's got a motor-driven reel, but somebody still has to, get it into position. And then, of course, the fully automatic one, you just push a button and it does what it's supposed to do, right? So definitely, we want to make sure that we include these pool covers whenever we have a home that has an outdoor pool. Let's talk a little bit about saunas. For the saunas, we want to make sure that we've got some ventilation openings here. There's some requirements for not the sauna necessarily itself, but for the room, right? So we want to make sure that the room is going to have some ventilation openings, right? That they're located near the top of the entry door. We also want to make sure that if we've got a gas-fired sauna heater, that the combustion air intake, that it's located outside the sauna. That may mean that it is located in an adjacent dressing room or something. It may not necessarily be outside. And so if it is in a dressing room, right, then we want to make sure that there's either there have been some provisions so that you don't have accidental contact between occupants and those vents, right? those exhaust vents because they're hot, right? And then you also want to make so you either have some sort of provision so that you don't have accidental contact, or you have to have some warning signs to let people know that you've got some hot surfaces in this place, in this space, and don't touch them. You also want to have a warning sign if you've got the combustion air intake in that dressing room as well, to make sure that it doesn't get blocked. So that there's no furniture, there's no curtains or anything like that in front of that device. For the heater itself, we want to make sure that that the heater has some guards so that there is again no potential for accidental contact with that. And we want to make sure that we've got access for maintenance, right? So we want to make sure that we adhere to the manufacturer's requirements for maintenance access on all sides, right? So we want to make sure that we've got those appropriate clearances there. And we also want to take a look at those sauna heater controls, right? We want to make sure that the maximum room temperature doesn't exceed the allowable, right? The maximum allowable by code, which is 194 degrees, right? We want to make sure that we see this 1 hour again, right? So this one is not an override. This is actually the use of the sauna heater. So if you've got a sauna heater that has a timer, right, that's controlling the burners, we want to make sure that it does not exceed 1 hour of operation, right? So that 1 hour, that's a key thing that we're seeing, that time slot there. Let's take a look at snow melt systems. We know that snow melt systems offer a lot of benefits, things like safety, right? We know that, unfortunately, lots of people have, every year there are people that have, heart attacks or other, heart issues while shoveling snow, right? So snow melt systems can help alleviate that, right? But snow melt systems can also use a lot of energy, right? They can use almost as 2 times as much energy as the heating system. When you look at it on a square foot basis, right? So we want to make sure that they operate only when they're necessary, and so we want to make sure that they've got certain controls in place so that they only operate when necessary. So we looked previously at the piping system, but here are some of the controls that you may see with that snow melt system, right? So with the snow melt system, you're going to have that outdoor air sensor that's going to be looking at what the temperature is outside. And then you're going to have obviously that system controller that's controlling what the boiler itself or the snow melt system, whatever it may be. It may be a boiler, it may be a specific heater designed for that, but it's going to be controlling that. Now, there are no specific code requirements to the snow melt system piping, so you just want to make sure that you follow the manufacturer's instructions. However, there are some criteria for the snow melt controls. So wherever you've got a snow melt system, we want to make sure, again, that it's only operating when it's necessary. So you've got some automatic controls that are going to turn it off when the pavement temperature, right, is above 50 degrees and there's no precipitation, right? So we don't need to be, heating the pavement if it's already warm outside. So if the pavement temperature is 50 degrees and there's no snow falling, there's no rain, no sleet or anything like that, then we want that snow melt system to be off. We also want it to be off if the outdoor air temperature is above 40 degrees. So when the outdoor air temperature is above 40, we don't need it as well, right? And just a note here, that snow melt system, in the code, we call it, it's referred to as a snow melt and ice system because it can be the snow on the ground or it could be snow on the roof. And so we, at the roof and the gutters. And here we would use those systems to help alleviate those ice dams that we are, prone to here in Michigan. Let's look at some other options for above code things that we could possibly do. Here we might consider a heat trace system, right? So we've got a heat trace system that we might see being used for water piping, for example, that may be on the perimeter of a building. I used to live in an older apartment building years ago, and as it is with oftentimes with homes as well, the kitchen sink is on a perimeter wall because, the thought was, oh, you might want to, look out the sink as you're, chopping vegetables or washing dishes or what have you. And so those tend to be on, we're seeing them now be placed in the interior of the space, but traditionally have been on an outside wall. And in this apartment building that I lived in, my kitchen sink was on a perimeter wall, and the pipe was prone to freezing, right? And so, a heat trace system would have been really nice there. Now, there's not a requirement to have a heat trace system on systems here in Michigan, but if you choose to have one, then there are some requirements around any that you may choose to have. And one of those requirements is that it has to have some automatic controls to modulate the energy input based on when hot water is likely to be used. You have to have some sort of schedule that's going to say when hot water is likely going to be used. And then you're going to have, you're going to be modulating input energy based on that, right? You want to make sure when you've got the system in place that you're using self-regulating cable, not mineral insulated cable, because that type of cable could overheat. If, for example, it were to cross itself, it would overheat, and that could create a problem. To avoid that, we want to make sure that we're using self-regulated cable, right? And the last system that we'll look at is drain water heat recovery systems. These also are not something that are required right now here in Michigan, but you may find a homeowner that is interested in utilizing this technology. These include a heat exchanger that would recover heat from hot water that's used, for example, in the showers, the bathtubs, or the dishwasher, the clothes washer. The heat exchanger may have storage capacity to it or not. If you don't have one that if your system doesn't have storage capacity, then you really only have the ability to use it when there is simultaneous use of hot and cold water. So, for example, during a shower, but you wouldn't be able to use it for example, for a dishwasher or anything else. But what these do is they preheat the incoming cold water that goes to the fixture, so out to the faucet, right? And this allows you to reduce the amount of heat that the water heater needs to provide. And sometimes, if you've got a properly sized water recovery system, you may actually even be able to downsize the water heater itself, right? So you can put in a smaller water heater if you've got this drain water heat recovery system. So we're seeing this, and this is a technology that another example of technology that we've seen in commercial spaces that is making its way into the residential space, right? Into residential environments, because it's relatively inexpensive to do, and you get a relatively decent payback, right? So you can see paybacks, simple paybacks with these systems from 2 to 5 years, maybe 7, but certainly no more than that. The system to install these is $300 to $500, right? And so if they can offer some significant savings, we may see homeowners again looking for this type of technology, right? When we do add this, again, this is not something that's required, but if we do have a system, then there are some requirements around it that code does require. And one is to make sure that we limit our pressure losses, right? And so we want to make sure that we limit those pressure losses depending on the number of showers that we have in the home, right? So it's either going to be 3 or 2 psi as a maximum loss limitation based on the number of showers that we have in the home. All right, so that is our session for today. If there are any questions, I will entertain those. And while we're looking to see if you have any questions, I'm just going to We've got a couple of poll questions, which we're going to throw out at you as well. So John, if you want to get those ready, we'll come back to those, but I'm going to advance to the next slide so that we don't forget to let you guys know about the next session. So the next session is going to be August 12th. We're going to be talking about solar applications, and the instructor for that is going to be my co-instructor, Chris McTaggart. He's going to be returning, and we've got a really great session for you planned there on the 12th of August, and it will be at 11 o'clock. So same bat time, same bat channel. I'm aging myself right there, or dating myself right there. But yeah, we'll see you guys hopefully next week to talk about solar applications. That is one of the hottest above code technology that we're seeing folks really begin to ask for. There's a lot of interest there these days. So now we're going to go back and we're going to do a couple of poll questions while we're waiting. And let me switch screens so that I can see the polls and also see if there are any questions that came in. And there are no questions. So let's see here. So our first question here is, oh, you just put them all up there. Okay, we'll go ahead and throw them all up there. I thought we were going to do them one at a time. No worries, though. So yeah, we've got a couple questions for you here. Let's just kind of go through them. So I'll be quiet for a couple of minutes and give you some time to think and to answer the questions, and then we'll chat about the answers. While you were doing that, I'm just going to kind of give you a little couple of fun facts that I came across recently about our utility companies here in Michigan, our largest utility. So, Consumers Energy, we talked earlier, I mentioned earlier that they've got a couple of solar installations that are going on in the state. We talked about the Sunfish Station, but they've also last year they started a solar energy center in Muskegon. It's going to be powering about 40,000 homes in Michigan here, and then they've got the Liberty Farm Solar that's going to be over in Kalamazoo County. It's going to be providing some solar as well. And fun fact about Consumers, they power the Mackinac Bridge, right? Which I don't know if you guys know, but several years ago now, I guess in around 2010, it was named one of the historical civil engineering landmarks in the country. And so I thought that was just an interesting fun fact about Consumers. And obviously DTE powers the Ambassador Bridge here in the Detroit area. And they do that actually in partnership with Windsor, with a Canadian power company, particularly for the Blue Water Bridge. They do that in conjunction with the Power Distribution Company, is the name of the Ontario utility that's over there in Sarnia that they do that in partnership with. We've got just a minute here left. I'm going to go ahead, John. Do we have some answers that we can show? Okay, we've got them. All right, let's see here. All right, so let me pull this up here. So for the first question, the color corrected temperature that gives you that warm, fuzzy feeling. Absolutely. Everybody got that 100%. 25 Kelvin. That's absolutely correct. That's that warm and fuzzy yellow tinged light that reminds you of a firelight, right? What's the longest time that a pool heater can be run in bypass mode? And most of you got that one correct. That is 24 hours. So it's just one day, one full day, 24 hours that we want to make sure that we limit that. Outside of that, we want to make sure that we get that heater back in that system so that we're maintaining that temperature. We don't want that pool water temperature to drop too much. What is the maximum temperature, room temperature for a sauna? That temperature, the majority of us got that correct as well. That is 194 degrees. We want to make sure that we don't exceed that temperature for those saunas. And the cutout temperature for pavement temperature for snow melt, that one was kind of split. So about half of us got it right, half of us got it wrong. There we want to make sure, and it's kind of tied to the next question as well. What's the outdoor air temperature? So, with the outdoor air temperature, we all got that one correct. 40 degrees for that outdoor temperature. So the pavement temperature, the cutout temperature for pavement is 50 degrees. So we want the air temperature to be at 40. We cut out the system, and for the pavement, we cut out at 50. And that is our time for today. So I thank you guys so much for joining us. I hope that you found this informative and valuable. And we look forward to seeing you next week at 11 a.m., where we'll be talking, where Chris McTaggart will be talking about solar above code systems. Thanks so much, everybody. Have a great day. Goodbye.